Okay, we're continuing learning how to solve quadratic equations in different ways. I've been making videos on how to do this. We've already done one where we're taking square roots of both sides. We've also looked at how to factor a quadratic equation to make it into something you could solve. We also have seen how to complete the square in order to solve a quadratic equation. Well, in some cases, you can't do any of those. The type of equation it is just won't let you do that nicely. You can complete the square, and we're going to do a little bit here with uglier ones, but eventually you get to where you just need a nice formula for it, and the quadratic formula really works. What I don't like, though, is just making the quadratic formula seem like it just came out of thin air. That's not fair. Math shouldn't seem like it's magical. It should make perfectly good sense. And so if you get into the middle of this video and you start panicking and say, I have no idea what's going on, you're welcome to just stop it and go on to the video where you learn about how to use the quadratic formula. But until then, if you want to hold on and see where this comes from, that's what this video is for. Okay, so I'm making one that's kind of in between these so you can see where it comes from. It's called developing the quadratic formula, but be aware you kind of need to be a little bit brave about some algebra. Okay, so here we go. If you're solving a quadratic equation that has a number out in front of the x squared, okay, we need to deal with that somehow, and you might notice that each one of these things is divisible by 2, so I can just do that. I can divide everything by 2, and that takes it down into an equation that we should be able to do okay with. If I add 6 to both sides just to get rid of that negative 6 there, put it over on the other side, and then I can say, look, I really wanted to have the number 4 here so that this would be a perfect square, because half of negative 4 is negative 2. When you square that, you get 4. So I'm going to put a 4 there, and of course I'll add a 4 to the other side. Okay. So now this right here is a perfect square, and I can factor it down this way. And over here I can combine 6 and 4 and get 10. And I can go on my way. And I'm not going to worry about finishing it. You've done lots of problems like that. But you can see you would square root both sides. You get it plus or minus square root 10, and then add 2 to both sides. Well, what happens when you get something that looks uglier, like this? 3 is not going to divide nicely into negative 7 and a negative 4. Well, we can still do it. If I divide by 3, I get x squared minus 7 thirds x minus 4 thirds. Of course, 0 divided by 3 is 0. Okay, let's clean it up just a little bit, if you will, by putting the 4 thirds to the other side, making it positive. And then this is going to get kind of ugly here, because the number I want right in here is going to be half of that squared. Okay, well, how do you get half of negative 7 thirds? Well, you multiply it by 1/2, so you get negative 7 sixths. Okay? But I also want to square that, so when I square that, I'm going to get positive 49 over 36. Okay, so here I go. I'm going to add 49 36ths to both sides. Well, that's not pretty, but it's doable. Okay. I'm going to get rid of this down here just so keep having enough room to work here. So now I've got this thing as a perfect square trinomial. I can write it in factored form. You'll remember that the number here is half of that, so half of negative 7 thirds was negative 7 sixths. And over here, well, let's see, this is going to get a little bit ugly, but if I make that into some number with 36 in it, then I'll have a common denominator there. So it looks like I'll have to multiply the top and bottom by 12. So I'll get 48, sorry, by 12. So 48 36ths. Okay. So now 48 36 plus 49 36 is what? 97 36. So that's what we have right here, 97 36. Okay. Square root both sides, just like we had before. You get plus or minus the square root of, in fact, I'm going to do the top and bottom separate. Square root of 97 over square root 36. Well, we're in luck, because even though 97 doesn't square root nicely, 36 sure does. Okay. So now I've got x minus 7 equals plus or minus root 97 over 6, and I can add 7/6 to both sides just like I did before. So I'll have 7/6 over here, plus or minus square root 97 over 6. Well, I've got my answer. It's done. It's doable. Not very pretty, but it worked. Okay. Well, what we find is that eventually that gets just too complicated. I shouldn't say too complicated. We get tired of doing this thing with all these fractions and having to redo all this work. And you may have noticed we've always done the same thing. We said, okay, look, let's get the thing cleaned up so we don't have a number here. But then we said, the number I want here is going to be half of that squared. We put it there. We put the same thing over there. We wrote this thing down as a perfect square, from a perfect square trinomial to a binomial squared. And we cleaned up all this mess over here. And then we did the same thing we've done before. We square root both sides and simplify. Okay? Well, you get tired of doing that after a while. Okay? So what we're going to do is we're going to do it one more time, but I'm going to put letters in there instead of numbers. So instead of having numbers in front of the x squared, a number in front of the x, and a number by itself equals 0, I'm just going to put the letters A, B, and C. And I'm going to redo all of the work once again just to make sure that just to crank it out one more time, and when we're done, we'll have x equals a big expression with a, b, and c in it. Okay, and that'll be nice because then when we have a quadratic equation to solve, we can just put in the numbers for a, b, and c. Okay, so here we go. Not going to be pretty, but we'll get it done. Let's divide everything by a first. Okay, just like we've done before, we divided by the number out in front. Now, I'm going to get this c over a out of the way. I'm going to put it over on the other side by subtracting it. Okay. And now I'm going to ask myself, and it's not going to be pleasant, but I'm going to get the job done here. What number do I want right here? Well, it has to be half of that squared. So here we go. We'll do it down here. Half of b over a is b over 2a. Okay? And then when we square that, we'll get b squared on top, and we'll get 4a squared down below. So here we go. We'll add b squared on top and 4a squared down below. Well, I've got to add it over here. If you don't mind, I'm going to put it in front of this negative c over a. So b squared minus, or over 4a squared. Okay, so just like we've done before, we said, what do we want right here? And we added it on both sides. Okay? Let's make some room down here by getting rid of this. Okay. Now, we have a perfect square trinomial here, just like we've always liked to have, so we can factor it now. Again, the number right here is going to be half of this number, so b over 2a, that's half of b over a squared. And then, oh my, look at this mess right here. Okay, well, I can't combine these things until I have a common denominator. Okay, so if you don't mind, I'm going to multiply this fraction, c over a, by 4a on top and bottom. Okay? And the reason I did that is because I wanted to have a fraction that had 4a squared in here. This had an a, but it didn't have a 4, and it didn't have an a squared. So I multiplied it by 4, and I multiplied by another a, so I get a squared. And of course, I had to put the same thing on top of the fraction. Okay? So this whole thing right here, this fraction, becomes 4ac over 4a squared. Okay? Now these two fractions will have a common denominator of 4a squared. Okay? So here I go. I'm going to have on the bottom 4a squared. On the top, I'm going to have b squared minus 4ac. Okay? Remember, we multiplied c times 4a, got 4ac. Okay? So as ugly as it is, that's what we've got. We've done exactly the same thing we've done for all the other equations. We said, let's get the a out of the way first. And then, so we divided everything by a. We got this c over a over to the other side to get it out of the way. And then said, look, what do I want right here? And it has to be this thing's cut in half squared. So I did that. It was as ugly as it was. We ended up with b squared over 4a squared. And it's what we added to both sides. And then we factored down here to get a squared binomial, and then we had to clean this mess up here into one fraction. So now we've got it done. Now I can square root both sides, just like I've done before. And on the top, I'm going to have the square root of b squared minus 4ac. Don't forget plus or minus. On the bottom, you'll notice that, well, here, I'll write it. Square root of 4a squared. Okay. Well, let's clean this up a little bit. The top, there really isn't any cleanup you can do. All you can do is just write b squared minus 4ac. Okay. But down below, the square root of 4a squared, well, it's going to be easy. Square root of 4 is 2, and the square root of a squared is just a. So you'll notice that now I have x plus b over 2a equals this fraction, okay, which also has a 2a on it, interesting enough. Okay. So now we'll subtract b over 2a from both sides. We'll get x equals negative b over 2a plus or minus the square root of b squared minus 4ac, that was this mess up here, all over 2a. Okay. And so what we're going to end up with, if you don't mind, I'm going to combine these into, oops, that should be an a down here. We're going to combine these into one fraction because they have the same denominator. Okay. So I'm just going to write, negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Okay? Now, as ugly as that is, what we found is, hey, x squared equals this thing here. Why is that so nice? Okay? Because if you get an equation that's in this form, it's got an x squared, a number in front of x squared, plus another number in front of x, plus a number equals 0, then you can take all these numbers, a, b, and c, and just put them into this formula, and you'll have your answers. Okay, let's do one. Let's use the one we had before. 3x squared minus 7x minus 4 equals 0. Well, let's identify a, b, and c first. Okay, a is 3, b is negative 7, and c is negative 4. Okay? And that formula was x squared equals negative b, in other words, the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. So now we'll just take all those numbers and put them into the formula. The opposite of b is 7, right? Because b is negative 7, so 7 plus or minus the square root of, well, b squared is negative 7 squared. So I'm just going to write 49 minus 4 times a is 3, c is negative 4. Okay, we put all that under the big giant square root sign, and then big huge fraction bar, and then 2 times a is 6. Okay. So now I'm going to pause and calculate here. Okay. You can see I used my little online calculator here. So then I ended up with 97 inside the square root sign, because 49 minus 4 times 3 times negative 4 was 97, all divided by 6. Okay, and that's what x equals. Okay, so that's the same answer we had from before when we did this problem. Okay, although we had it separated into two fractions, but they could be combined into one, 7 plus or minus the square root of 97 over 6. That's the same answer we got here. But you'll notice we didn't have to go through all that that ugly algebra anymore. We just took all the numbers, a, b, and c, and we put them into the formula and got our answers. That's the beauty of the quadratic formula. All right?